Hi there, thank you for joining me and welcome to the wonderful world of quadratic equations. We're going to look at all the skills that are generally asked in foundation papers. We're looking to complete tables of values, we're going to draw the graphs, we're going to solve the equations using the graph and find turning points. I really do hope you find this useful. What I think we should do is break this topic down into sections. First, I want to have a look at the table of values. Then we'll move on to actually creating a quadratic graph and finally look at the information that we need to be able to extract from it. So let's have a look at this first line. It says complete the table of values for the equation y equals x squared plus 2x minus 1. Now straight away the information is in there to tell us that it's going to be quadratic because it has the x squared. A quadratic graph always has x squared. If it is x without a power, then it's going to be a straight line graph. If it is any power higher than 2, it's going to be something else. So x squared, we have a quadratic graph. Let's look at the table of values. So here is the standard format of a table that you'd expect to see in an exam question. In fact, I'm going to look to do this two different ways because I do think that relying on a table like this sometimes demands quite complex mental arithmetic. And if that's not your skill, there is a way to do this on a step-by-step basis. First of all, let's just look at it this way. We have all the values of x. So when we are plotting the coordinates, these are our x values for the graph. We need to find the y values. And we do that by inserting each value of x into the equation that we have here. Now this is where the mental arithmetic comes in because we have to start with minus 4. So we need to put in minus 4 into this equation. So we end up with y equals minus 4 squared plus, and then it's 2 times minus 4 minus 1. Now you can see that doing this mentally can be quite a complex process. Minus 4 squared, that is 16. We then have plus 2 times minus 4, so that's minus 8, and minus 1 on the end. So 16 minus 8 minus 1 gives us 7. When x is minus 4, y equals 7. We then have to do the same with minus 3. So we end up with minus 3 squared plus 2 times minus 3 minus 1. So minus 3 squared is 9. Then we have to do 2 times minus 3, that's minus 6, minus 1. So 9 minus 6 is 3, minus 1 is 2. So again, that goes into the y value for the corresponding x is minus 3. And we need to do this all the way along this table. Now, I'm not going to do every equation here. I will fill the rest of the table in. There is one thing you can take a look at here, and that is that a quadratic graph is symmetrical. Therefore, there is going to be a pattern appear along this bottom line. And if you take a look at it, we have 7, 2, minus 1, minus 2, minus 1, 2, 7. It's repeating itself as if it were in a mirror. If you can spot this pattern, you can use that to find some of the values without doing all the arithmetic. However, I still think this is a difficult process, and I want to have a look at breaking it down. So what I've done here is kept the top row of the table exactly the same, but I've inserted more rows. And down the left hand side I have broken down the equation into its parts. So we have x squared in the first row, plus 2x in the second row, and minus 1 in the third row. Y is then at the bottom as before. This gives us a chance to work out the numbers one part at a time. So if we work on this first row, we have x squared. So for each of these values, we square it. So minus 4 squared is 16. Minus 3 squared is 9. Minus 2 squared is 4. 1, 0, 1, and 4. We then look at the plus 2x. So don't forget, we're looking at minus 4. So plus 2 times minus 4 is minus 8. 2 times minus 3 is minus 6. 2 times minus 2 is minus 4. 2 times minus 1 is minus 2. 2 times 0, 2 times 1, and 2 times 4. The next part of the equation is the simplest. It's minus 1. So we simply insert minus 1 all the way across for each value. To then find our corresponding values of y, we look at the three parts of the equation. Ignore the top row, just look at the colours that are marked in purple here, and we simply add them together. 16 minus 8 minus 1 is 7. 9 minus 6 minus 1 is 2, and so on along the table. And we come up with exactly the same values as we did with our previous table. It's simply an alternative. It takes away having to work out the algebra for each step. We do one little sum at a time and add up for the total. What we have here then is corresponding x and y values for x from minus 4 up to minus 2, and we now have the information we need to actually plot the graph. Really, at this point, the difficult work has been done. We just need to take care that we plot the coordinates correctly. So here's the same table of values, and I've drawn the corresponding graph that I need. In an exam, quite often the axes are drawn for you, but if you do need to draw one out yourself, you can see what I've done here. For the x values, I've taken the x-axis from minus 4 to 2, and similarly the y goes from minus 2 up to 7, so those are the values that I've chosen for the graph. Let's plot these then. Our first coordinate is minus 4, 7. So minus 4 along the x, and 7, we're going to plot it just there. Minus 3 and 2 brings us to here. Minus 2 and minus 1 is here. We then have minus 1, minus 2. We have 0, minus 1. We have 1, 2, and we have 2, 7. This now is the part where we need to take care. We might be asked questions about this graph, so we need to draw it quite accurately, even though you're going to do it freehand. And that is probably the best I can do. If you look at the graph closely, you can see we have a nice smooth curve. It is symmetrical, and this is the important thing about this graph, that if we take a line down the center here, we have clear symmetry with the coordinates equaling each other on either side. It is important that you try to be as careful as you can when drawing this, because it then tells you whether or not you've got any of your coordinates wrong. If you happen to have posted this one, say, here, then when you drew your graph, there would be a clear distortion in the curve. We're going to continue using this particular graph to look at some of the questions that you might get asked when dealing with quadratic graphs. And this is the first one. You may be asked to actually solve the equation. Now, if we look at the equation of the graph, y equals x squared plus 2x minus 1. This is repeated down here, x squared plus 2x minus 1. But rather than saying y equals, it says equals 0. What we have been asked to do here is find the x coordinates when y is 0, because that's all that's happened here. The y at one end has been replaced with 0. So we are being told that y is 0 and asked for the values of x. This can be done using algebra, but we are being asked specifically to use the graph. So let's have a look at the graph and identify where y is equal to 0. Well, of course, y equals 0 is along the x-axis here, and in fact there are 2 points. There is a point here where y is equal to 0 and a point here. In other words, it is the 2 places where the graph crosses the x-axis, because at these points y is equal to 0. We then need to give the values of x at these points in order to solve the equation. Well, this is where drawing the graph carefully by hand helps, because we cannot give a totally accurate answer here. We have to look at the graph and look at our own drawing. If we look at my graph here, the value of x on the right hand side one looks as though it's about at 0.4, and on the left hand side here it's probably around minus 2.4. The examiner will allow a slight degree of inaccuracy, but the more carefully you draw your graph, the more likely you are to be correct here. So, summarize. Solving the equation means finding the x values when y is 0. We look at the graph, we look at the 2 points where the graph is crossing the x-axis, and we read off the x values. And the second common question that you may be asked is to find the turning point of the graph. Now, in this particular graph, it's quite an easy thing to do, because the turning point is quite simply the very bottom of the curve. It is where the line stops going down and starts going back up again. It's easy in this graph because we actually have a coordinate on the bottom of the curve here. So we simply read this off. In this case, the turning point is -1, -2. Now, there are instances where sometimes you find you have drawn a graph and you haven't actually plotted a point there. It may be there is a point either side and you have to find that center point for yourself. You've actually drawn the line but not plotted a point there. So just for this purposes, let us imagine that we don't have a coordinate at the bottom there. It's not quite so easy now to see exactly where that point might be. The way we find it is we use these 2 points either side. We find a pair. We could use this one and this one, but we do need a corresponding pair. If we look at their coordinates and look at the x coordinate, we find the x coordinate for this one is -2 and for this one is 0. The first thing we do then is find the middle point between these two. So the number in between 0 and -2 is -1. So the x coordinate is therefore -1. What you then need to do is put this coordinate into the equation. So if you do that, put -1 into the original equation from the question, that will then give you the y coordinate. In this case, as it happens, it's already been done for us here, so we know that it's -2. So summarize again. If you need the turning point and you don't have an x already marked there, find an opposite pair, look at their x coordinates, and using those, in this case 0 and -2, you are looking for the center point, which is -1. That gives you the x coordinate. Put that into the equation and you will find the corresponding y coordinate, and that is your turning point. I think the best way to summarize this is to work through another example. So here we have the equation y equals -x² minus x plus 2. First of all, we note it's a -x². This has two effects. Firstly, it changes the shape of the graph, as we'll see when we draw it, and secondly, it adds to the complexity of the arithmetic that we're about to do, and you might see why using the step-by-step box that I used in the earlier example might come in useful here. But let's work through it. First of all, we have x equaling -3. Using BIDMAS then, the power we do first, so -3 squared, well, -3 times -3 is 9, but it's -x², so it's -9. The negatives always try to confuse. Then we have to take away x. Well, taking away -3 means we are adding 3. The next step is simply to add 2. Therefore, we end up with -4. Let's use x as -2. Minus 2 squared is 4, but it's minus x squared, so it's minus 4. We then take away x, again taking away a negative means we are adding it on, and finally we add 2. Minus 4 plus 2 equals 0. So our first two values, minus 4 and 0. We now have x is minus 1. Well, minus 1 squared is 1, but it's minus, so it's minus 1. We then have minus x, taking away a minus is a plus, so we have plus 1, and then we have plus 2 on the end, so minus 1 plus 2 equals 2. Well, when x is 0, well, x squared is still 0, minus x squared is 0, take away x, still 0. All we actually have here is the plus 2, so that one is also 2. We can see possibly a pattern forming here, but I'll continue. The next one is where x is 1. X squared is 1, therefore minus x squared is minus 1. Then we're going to take away 1, so minus 1, and then we're going to add 2. So minus 1 plus 2 equals 0. The last one then, 2. 2 squared is 4, so we have minus 4. Take away x, so take away 2, and then add 2. So minus 4 plus 2 minus 2, we are still at minus 4. Not so simple this time around. Have a look at the step-by-step box if you think that might make things easier for you. Now we have the values of x and the corresponding values of y. We're going to draw the graph, we're going to solve the equation, and we're going to find the turning point. Okay, let's first of all get the coordinates plotted on the graph. A slightly different scale. I'm going up in 2s on the y-axis and 1s on the x. But no matter, I can still plot the coordinates. X, y, minus 3, minus 4. So minus 3, minus 4, we're starting down here. Minus 2, 0 is just there. Minus 1, 2 gives us there. 0, 2 is here. 1, 0 is here. And 2 minus 4 is down at the bottom here. This time, if we look to complete the curve, you will notice immediately that in this particular graph, the curve is inverted, it's upside down. And this is simply because it is a minus x squared. This will always be the case. Again, my line may not be perfect. I've drawn it freehand as you would have to, but try to make it as smooth as you possibly can. Now let's have a look at solving the equation. We were asked to solve x squared minus x plus 2 equals 0. Again, we are looking for where the line crosses the x-axis, where the values of y are 0. In this particular graph, it's been given to us because there are in fact two coordinates on that line. Therefore, we know that where y is 0, which in our box is here and here, the corresponding x coordinates are x equals minus 2 and x equals 1. So that is solving the equation. Our last task is to find the turning point, and this can prove to be the trickiest part depending on the numbers. Visually, we can see the turning point. It's here at the top of the curve. Unfortunately, we do not have a cross right on the point this time. Therefore, we do not know the exact coordinates. We're going to have to work them out for ourselves. The way we do this, we take a point either side and use two corresponding points here. Using the fact that the curve is symmetrical means these 2 points are equidistant from the turning point. So if we use their x coordinates, which are minus 1 here and 0 here, that means the turning point is halfway between the two. So on the x coordinate, the turning point is minus 0.5. Here's where it gets a little tricky. We need to put that value into the equation at the top. So we are looking for minus x squared. Well, x is minus 0.5. So to write that, we need to put minus minus 0.5 squared. Then it's minus x. Well, x is minus 0.5, so to take that away it will be plus 0.5, and on the end plus 2. Work that all out and you end up with 2.25, and that is your y coordinate. So the turning point is minus 0.5 plus 2.25. Well, that last part was certainly a little tricky, and I do recommend you familiarise yourself with the use of a calculator, because that's the best way of working out the y coordinate. If that has been of use to you, please do subscribe to my channel. I have plenty of other videos at this and other maths levels. Thank you.